How are LLM typically trained? Answer. Large language models LLM are typically trained using a transformer-based neural network with billions of parameters. This neural network is designed to learn complex relationships between words and phrases by analyzing massive datasets of high-quality text and code. The training process involves predicting the next word in a sequence based on the previous ones, and then adjusting the internal parameters of the model to improve its predictions. The training data is sourced from a vast amount of text and code, which provides the raw material for the model to learn language patterns. The model is trained to predict the next word in a sequence, and this process is repeated millions of times. As the model makes predictions, it adjusts its internal parameters to improve its accuracy. This process is repeated until the model has learned to recognize patterns and relationships in the language. Once the model is trained, it can be fine-tuned for specific tasks. This involves using smaller datasets to adjust the model's parameters towards a particular application. There are three main approaches for fine-tuning: zero-shot learning, few-shot learning, and fine-tuning. Zero-shot learning involves training the model to respond to prompts and requests without specific training, although the accuracy may vary. Few-shot learning involves providing relevant examples, which significantly improves the model's performance. Fine-tuning is a more intensive version of few-shot learning, where the model is trained on a larger dataset to optimize performance for a particular task. In summary, LLM are trained using a transformer-based neural network with billions of parameters, analyzing massive datasets of high-quality text and code. The training process involves predicting the next word in a sequence, adjusting internal parameters, and fine-tuning for specific tasks. This complex process enables LLM to learn language patterns and recognize relationships, making them powerful tools for natural language processing and generation.